You might be wondering how to create a string that spans multiple lines. The ASCII and Unicode standard contains characters for indicating a new line, a tab, and other special characters. The way these characters are represented in strings is by using what is known as an escape character. An escape character is a character that indicates both it and the next character together form one character with a special meaning. In most programming languages, the backslash is used as the escape character. The newline character is specified by a backslash and the character n, since newline starts with n. These two characters together indicate the string contains a newline character, so when you print it, it moves down to the next line before printing any characters after it. Let's debug this example that demonstrates the newline escape character. We've created a string s with hello \n world. If you count the number of characters between the quotes, you might think the length of s should be 12. But when we step over it, we see that it is 11. That is because the backslash tells Python to interpret both it and the next character as a special value, so together they form one character. When we print s, we can see that it prints hello on one line and world on the next line. Note we don't put a space before the w in world, otherwise there would be a space at the beginning of the line containing world. If we put \n at the end of the string, we see that it moves down 2 lines because the \n in the string moves down to the next line and the print function moves down to the next line by default. If we try to enter a string in the console with a \n, it does not work. When we type in hello \n world and press return, we see that the length of s is 12, not 11, as it was when we created the string in Python code. When the backslash is used as input from the user, it is not treated as an escape character. Only when you've created the string in Python does the backslash act as an escape character. If you want a backslash in a string you create with Python, you use 2 consecutive backslashes. The first backslash is the escape character, and it, along with the backslash after it, indicates an actual backslash in the string. So when we entered hello \n world in the console, Python internally stored s as if we wrote it as it appears on line 12 with 2 backslashes in a row. When we print out the length of this string, it matches what we entered from the console. The string s now has length 12 and prints out with an actual backslash. Using the ORD function, we can see that \n is one character. Remember that you can only send ORD a string of length 1. The ASCII and Unicode value for the \n is 10. Now we'll look at how to read the contents of a file in Python. The standard way to process files in most programming languages is to associate the variable with a file and then access the contents of the file through that variable. In Python, this is done using the open function that is built into Python, like input and print are. The open function allows you to send it strings. The first string is the name of the file, and the second string indicates how to treat the file. In this example, we send it the string r because we are reading from the file. The open function gives you back a file object that has methods just as the strings and graphics objects we used have methods. In this case, the file object will be of type text.io wrapper, but we won't worry about that detail. In this example, I've called the variable inFile since it is an input file we are reading from, but you can use any legal identifier you want for the file variable. The file name you send it must either be the full path to where the file is on your computer, or the file must be in the same directory as the Python program that is processing the file. For example, if this file happened to be my desktop folder, I could write it like this. But in this case, the file is in the same directory as the Python program, so we can just use letters.txt. The contents of this file is just a phrase that includes all 26 letters in the English alphabet. Let's debug this example so we can see the different techniques for processing a file. After opening the file, we call the read method on the file object. This reads the entire file as one string, and we assign it to the variable data. We can use PyCharm's variable view to see the string it read in. Note the \n when the file started a new line. This tells us when you press return in a file, the editor is storing the ASCII value 10 in its memory of the string representing the contents of the file. Note that there is not a \n at the end of the string. This is because I did not press return on the last line. If I did press return, we can now see the editor shows an empty line 4, and this would place a \n after the G in dog. If I save this and reran the program, the data string would have included a \n at the end of the string. As you should expect, if we print the string to the console, we do not see the \n characters, but instead it moved down the next line at each place where there was a \n. When you are done processing a file, you call the close method. This is very important here because Python keeps track of how far we've read in the file, and each subsequent call continues from that point. Since we've read the entire file with the first call to the read method, when we try to read it again, we get back an empty string, as we can see here. If we want to read the file again, we need to close it and reopen it. Opening the file resets how far we've read in the file to the beginning of it. We'll reopen it, and this time we'll use the file object's readline method. This reads the entire file in, but instead of storing it as one string, it creates a list where each item in the list is one line from the file. We can see it as a list with 3 items containing the lines from the file. Note the \n at the end of the first 2 lines, and no \n at the end of the third line. This is because I didn't press return when editing the last line of the letters.txt file. The readlines method starts a new entry in the list after each \, the file contains. If we print this out, we see it as a list. We'll close the file, since if we try to read it again, there's nothing left to read since we've read the entire file. We'll open it again and this time use the readline method. The disadvantage of the read and readlines method is they read in the entire file into memory. If you have a large data file, this may be problematic. The readline method reads one line each time you call it, so this first call reads in the first line of the file. Note that it includes the \n. When we print the line variable, it is going to leave a blank line after it. We now call readline again, and it reads from the current point in the file, which is the second line. This also contains a \n, and you can see when we print it, it left a blank line between the first and second line, because the first print call printed a string with a \n at the end. The second print will also leave an extra blank line after it, because the variable ends with a \n. We'll close the file so we can show the preferred way of processing a file a line at a time. Just as we can iterate over strings and lists, the file object allows you to iterate over it. At each iteration, the loop variable is assigned the string for the next line in the file. As with the readline method, we only end up with one line at a time in the computer's memory. We use the :-1 to remove the last characters we printed. As we step through it, we can see the variable line changes at each loop iteration. Removing the last character works to remove the \n, so the lines are not printed out double-spaced. But since the last line does not end in a \n, we remove the g from dog. Let's close the file and open it one more time, and we'll see a better way to do this. You may recall that the string class has methods named strip, lstrip, and rstrip. The strip methods returns a new string by removing any leading and trailing tabs, spaces, and newline characters. The lstrip method returns a new string but only removes them from the beginning of the string, and the rstrip method only removes them from the end of the string. In many cases, the spacing at the beginning of the string matters. For example, in Python code, the leading spacing does matter. But in most cases, trailing spaces do not matter. In fact, some code editors automatically remove trailing spaces at the end of each line when saving a file. So we'll use rstrip, which will remove the \n at the end of each line, but it won't remove the g in dog. So this version correctly prints out the line single-spaced.